All right. Hopefully everyone's on. Sorry, running a little late tonight. Might be a little bit short too. I actually lost the power adapter for my laptop, so I've got about 15%. Well, no, looking good. Actually, I think I'm good. So I think I'm going to be okay. All right. So actually, where did that come from? Weird. All right. Anyways, so let's get started. Today we're going to do another review of objects. We're going to be talking more about prototypes, and we're going to do a little bit of review of what we've already talked about, object composition and inheritance and whatnot. So we're going to first, again, go over the review, and then I'm going to try and describe prototypes using a couple different perspectives. I'm not getting into all the details of how they functionally work in JavaScript exactly, because it can get a little complicated, but I want to try and talk through it a couple different ways. We may even review this again on Thursday in class. I think maybe a hands-on exercise might make it a little more, help it click a little better. But I'm going to try my best just right here, and then might work through a couple of the homework problems or other questions that people have had, just to give some more example bits of code. So the first thing I want to do is do some review. And one of the first things that we did, or things that we learned in the last class, was the for each method on arrays. So I don't know if anybody remembers what this is, but it's just a useful method on arrays that will call a function every time you step, or for every item in the array. Really useful little tool. So I've got a small example bit of code here, and I'm going to go ahead and copy it all, but then we're going to, I think I need to copy it from the other page. Hey, Gizmo, how's it going? One of my dogs just walked in. I'm going to go ahead and copy it from here, and then I'll walk through what's going on in this bit by bit as hopefully another good example of using for each. So let's see how this goes. All right. Save as. So in this example, normally I'd like to try and type this stuff out, but I wanted to go with something that was going to be easier to work with sort of in this fashion. So what we're going to do is compute the total of a shopping cart. So I've got is an array of objects. Each object looks the same. It just has a price and a tax rate. This sort of same pattern that we've seen before in some of our other homework or other stuff that we've done in class, computing how much something costs in total. But this time we want to compute a total shopping cart, right? We want to compute the cost of everything. And since each item can have a different tax rate, we need to sum it all up. And the way that you want to sort of break that down when you're thinking about these problems, again, this is one of those challenges, is how do we learn to think about how to solve a problem? So, you know what, I decided I'm not going to do this. I'm going to go ahead and delete this. We're going to rewrite it from scratch. We'll see how close I get to where I was. That way we're building it together. But what you want to do is you want to think about what you're trying to solve piece by piece. And sometimes what's interesting is it's easier to start from the end and then decompose it bit by bit going backwards. So let's say, well, I know I want to get the total price of everything in the cart. All right. So if that's what I want to do, then I'm going to want some sort of function like compute cart total. And that's going to take a cart as its argument. And I don't know what to put here yet, right? I don't know what to put in that function. But what I do know is that I'll be able to store whatever I get out of that as my cart total and then print out the message that I want. Really useful. So this is sort of this backing into solving a problem aspect. We know we've got this shopping cart information. I know I'm going to want to be able to compute some sort of cart total. So now, if I were actually writing this a lot of times, I would even break this down very simply. I might do something really simple. I would just say 0. Like, I want to make sure that the rest of this code works the way I expect. And I'll check it and see, awesome. It's telling me that my cart total is 0. I actually want this to have a $sign in front of it, so I'll put one there. That's my code, $0. Now that may seem, to some people, it may seem trivial. That may seem like, wow, you really didn't do anything there. But an important aspect of building code is piece by piece testing your code as you work through it. And what I'm testing is that everything outside of this function works correctly. So right now what I know is that if I end up with a bug in this code and I haven't changed any of the code outside of here yet, barring if I had something wrong with my cart data, but if I didn't change anything in these lines down here, then I know that the bug is going to be inside of my function and not outside of it. And now I can start getting in here and I say, I know I want to return a total. So I'm just going to go ahead and create a total variable and even just change this, return that value. Let's test this out piece by piece. We're going to build this up using this for each. And there we go. Everything's good. Again, very trivial change, but I definitely recommend this being sort of the practice that you do is make a really small change, test that it works, and then make another small change. That way, when you do get around to having a bug in your code, something's wrong, it can only be most likely, or won't say only, but very likely that whatever bug is in your code is in that small section of stuff that you just changed. If you instead you write 20 lines of code all at once, change 20 things, then you could have a bug anywhere in there, or your problem could be coming from any of that. All right, so now somewhere in here, I want to iterate over the cart getting the total price of each item. Traditionally, we've done this using a for loop, but we want to do this not using a for loop this time. We use the for each. And that means that we'll do stuff a little differently than we would traditionally have done. One thing that we're going to do different is we're going to have a function that we need to pass in to our for each. That gets into exactly how it works. For each is, oh, let me get rid of some of this. Hold on. I don't like the way they did that. So if we do for each, we go back here. The tool will help tell me something about this. It tells me that what it takes is a callback function that's going to be run for each one of my items in here. So what do I need to do inside of this function, whatever this function is? Well, let me, for each item, I need to do a couple things. I'm going to put some comments here. I need to compute the price of that item, including tax. And then I need to add that price to the total. All right. So since that's actually a separate function, I can take those comments and I'm just going to move them up here and put those right above a function that I'm going to write to do this work. And I don't have to define it in here, although it's going to be a little easier defining it inside of my compute cart total. I'll sort of show you why in a minute. But I'm going to define this function right inside of here. And I'll say add item price to total. And this is going to take an item, not everything. But what I know now here is this guy is the function I want to call for each thing. So following that practice of doing a very minimal amount of code, let's say I want to call add item price to total for each thing. So this function is going to get called over and over. Let's just to test that it gets called, let's console log the item instead of doing anything else first. And let's sort of test this code. Let's see what happens. All right, think we're looking good. We go ahead and print out the price of each item or each item's object. So we know that we're iterating over it. We know that each one of them is getting put into here. So the next thing we know we want to do here is two things, right? We want to compute the price of the item, including tax. So we could do the item total price. We've done this many times. It's item.price plus item.price times item.tax rate. So easy enough there. And if I were to take these comments and put them right above my code where they do this stuff, that would fit right there. So that means I've got one more step I want to do inside of my function, and that is adding that price to the total. So total equals total plus item total price. Sort of doing these two simple computations in there. Let's check that out. And it looks like I've got a total price for my shopping cart, which is really cool. I didn't double check that that's right, but it looks like it's in the right space in terms of price. So I think we're pretty good. Let's see, 10, 1750, 1850. Yeah, I think we got it. So what's really nice here again is this sort of adds, or this sort of makes this code really easy. I got to hide the implementation instead of having to do all of the worry about how I step over each item in my array. This for each hides all that for me. And now this reads much more like a sentence. It says cart for each item in my cart. Yeah, it takes a little bit of work, but for each item in my cart, add that item price to my total. Now I said one thing that you were going to see was why it's nice that we defined this function in here. And the reason is because it has access to this total variable. Because otherwise, it would be a little bit of a challenge to update our total if we didn't define the function inside of here. And then we would have to sort of jump through some hoops. But because of, this is that concept of scope that I talked about, we have three different scopes in this program. We have this function scope. So within this scope, we have the item total price variable, but that only exists for each time that we run this add item price to total. Then within our outer scope here, we have total. And since that's in a scope that add item price to total is within, it has access to that variable. And then we have our global scope out here, and that's why we have to return something from our function to set a value here, because otherwise our global scope would not have access to our cart total. So that's just an example of using for each. I hope it's a good example of breaking down a problem too. I do intend to probably talk a little bit more on Thursday about just how to use some tools to help you break down a problem. Like when you see problems, what what should you be thinking about to help you learn how to break them down? What's going to help you sort of do that strategically? So the next things that we've got here, we're going to talk more about object composition and inheritance. This is also a review from last time. And I'm just going to touch on this real fast because these are concepts and these are something that you'll understand a lot better the more that you work with objects. Is objects can be composed of other objects, and objects can inherit properties from other objects. Again, as I said last time, the composition is sort of intuitive. It's not as hard to understand. The inheritance is the hard one, and that's why we spend more time talking about it. And building on that, we also discuss this object.create. This is yet another way to create objects. And I wouldn't worry too much about it in this case. I'm not going to dive into a lot of the details of object.create, but the gist of it is it's another way to create objects, and one of the useful aspects of it is that it lets you set your prototype object, which I'll get to in a minute, but that's really the reason I'm introducing it. Otherwise, it's not that different from some of our other object creation methods. So that's what we'll talk about now. Let's talk about the object prototype and what this means. And then I'm going to show you a couple images that hopefully help explain it a little bit more as well. So let me know if they help clarify a little bit. I think I'll code those examples, or at least the first example up before I try and show you the images. But the key thing about objects to know in JavaScript is all objects have a prototype. It's not referenced off of the prototype property name. That's not, or the key. That's not the way you get to it. It's sort of hidden. You can use something __ proto _ to get to it, but that's deprecated. It's one of these things that's sort of invisible to you naturally for the most part. But the prototype of every object is either another object or null when you reach the end of the prototype chain. And every object inherits properties, state and methods behavior from its prototype. And whenever JavaScript looks for a property of an object, it first looks on the object itself, and if it doesn't find it, then it looks on the prototype of that object. So let's go back to our character object that we had before, right? And this is reusing our code from last class. So I'm just going to go ahead and pull up the example that we had. I'll drop this guy over here in this examples folder. Pull up our example here. There we go, character objects, nice. So we had a whole bunch of different ways to create characters here. Let's focus on this one that we have down at the bottom here. And I think I'm going to, for the sake of starting with something a little bit fresh and working off of it, let me see here. Wait, is this the exercise I wanted? Let me double check. Oh, methods on prototype. This is the one I want, I believe. Yeah. So I'm going to start with this. And I'll copy it and create a new file to work with. We'll just call it prototypes. Let's collapse some of this stuff, and then we'll talk about this a little bit. I don't want any of this. In fact, I'm just going to go ahead and get rid of this stuff too for now. You know what? I don't even know why I actually started with this, because I'm going to create something a little different than last time. Here's what we're going to create. We're going to do a triangle instead of what we had before. And when we're creating a triangle, there's two different things, two different properties to set on your triangle: width and height. And that's pretty easy. We'll just set this dot width and this dot height. So what we get here, and again, this being one of these situations where I want to do sort of a minimal amount of work before I make it, or before I test my code. Before I add anything else, I want to create a triangle with a width of 3 and a height of 4. And then I'm just going to log it and make sure that I'm getting out what I expect right now. Now this probably won't tell me what I want, unfortunately. Let me see what it does. It might be smart enough to do that. Oh wait, not running the right file. Examples, prototype said yes. All right, we've got a triangle object with width of 3 and a height of 4. So that in itself, we're not doing that much that's interesting. But here's where we can get to some interesting stuff. And this is where we start talking about some of this prototype chain and what's going on. Is when we create a triangle from this triangle constructor, the triangle constructor itself has a prototype property that we can attach something to. Like, let's give it a color. Let's call it red. And what's going to happen is these properties are going to end up on the prototype of any object that we create. So if we look and run this code right now, we see nothing changed. It still prints out triangle, width height, width 3, height 3. But we can also do console.log triangle.color. And we get out red. And the key thing to understand about how this is working is what's going on inside of this prototype chain. Oh, this one used border, and it named this. But this is what's happening. We've got a triangle object. And in our case, our triangle object has a couple properties. It has width and height. In their case here, there's no properties on the triangle object. It's just triangle. And when it looks for the color, it doesn't see a property of color on the triangle object. Let me go change my code so that it fits this, so that it's a little less confusing. Let's just do border. Test it real fast. So when it looks on our original triangle, it sees a width and a height, but not a border. So it goes and looks at the prototype of that, which again, as I said, can be accessed using this __ proto property, but that's not guaranteed to last forever. Eventually, they're going to remove that support. And what it does is that means it looks at another object, and this other object does have a border property of red. And so it prints out the value of that as opposed to anything on the triangle. Now, there are some other interesting things here. So if we now add a border to our triangle, and we're going to call it blue, and then I'm going to log both of these things again. Does anybody have a guess what we're going to see when we log this? Based off what we've seen so far in the code. What do you think is going to be the output of this second set of logging after we've changed the triangle border to blue? Here, let me comment it out, run the code again so you can see what we were getting before, because I just got rid of it all. That might help you make a prediction. Will be blue. All right. And it's two triangles, one red, one blue. 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 All right, so let's see what happens here. We do get blue, but you notice something interesting about the output. Anything else interesting? Purple. I like it. Yeah, does anybody notice anything interesting about the output, what we got that was unexpected or different? Yes, that's a perfect description. It changed the original object, but not the prototype. It added this border blue not to our prototype. It added this property to the object that we have. And that doesn't mean that the prototype doesn't have that property anymore. It just means that it's not finding it because we've now added a border property directly to our triangle. So it finds it on the triangle first and never goes and checks the prototype. And to show you that, I'll go ahead and let me just reduce what we're getting printed out here. I don't know if this will work. I think it will, though. If I do our triangle and access the proto using this, and I do the border of that, I should, assuming this works, see red. And that's because that prototype object still has red as its color. We didn't change the color on that prototype object. We changed it. We added a property to our object, which is now hiding the property on the prototype object. So it no longer can read the property of the prototype object directly, because when you go and try and read the value, it finds it on your triangle. Now, building on that same thing, let's try this. What if I do if I set my prototype border to true? Let's see what happens here. Wow, that is, holy cow, that is a good description of what's going on, Jade. If people didn't see that, it says it has a hierarchical scan to see where it should place the update. And if the object's border property is found first, it changes that property. Yeah, that is what would happen too. Now in this case, because I'm changing the value on the prototype, it still isn't on our object, right? So I changed the prototype value instead of the one on my object. And we can show, I could walk through a fair number of other examples. Again, I think a little bit of a hands-on might be an even better way to really dig into what's going on with some of this. But I wanted to at least start showing you a little bit of this. And then we can, I'll show you a little bit more of what we get off of some of the prototype stuff as well. So let's say normally you're not really going to put a property like this down on your prototype because it doesn't make the most sense. So now let's start talking about a concept that's known as polymorphism, a big fancy word. But basically what it means is you can have sort of the same interface, and that's what I mentioned about inheritance is things can have the same interface but different implementations. And this is going to get into a little bit of some more object-oriented construction concepts, but I think it's going to make a lot of sense. So first I'm going to change this code, and I'm going to try and achieve pretty much the same thing that I have going on here, but I'm going to do it with a little bit different syntax. So what I want to do is, instead of using this constructor syntax, this is where I'm going to switch over to this object.create, which is a little bit more explicit prototype setting. This one is a little bit under the covers, so this one will be more explicit. So I'm going to create a shape object, and I'm going to set a border property on it of red. And that's all I'm going to do in there. And now what I'm going to do is, instead of having a constructor function like this, I am going to change my code a little bit. Let me double check my syntax on some of this myself. I don't do this very often. All right. So instead of using that constructor function, I'm just going to go ahead and create an object, my triangle, using this object.create syntax. And if you remember, we had to pass an argument to object.create. So first, I'm just going to pass an empty object, and then you'll see me change that in just a second. So now if I have my triangle, I want to add a width and a height. And we'll see what happens when let me go back to my original code, comment out this stuff down below. Just back to this original bit of code. And we should just see width of 3, height of 4, and undefined when I try triangle.border, and that's because it doesn't have any border property. But what's actually happening with this object.create is this argument is actually the prototype of your object that you're creating. And remember, I said it's just another object. So in this case, I'm just going to pass in this shape object that we created right up here as the prototype. And now if we run this code, we see pretty much the same thing we were seeing before. We see a width of 3 and a height of 4, and then red for our property. And if we go over and look at this tree, this follows even more directly this actual inheritance, because we named our prototype shape. And I just created an object, just a shape object, that this triangle inherited from and gets those properties. And if we do this little bit of code, we should see the same thing that we were seeing before, where we added the border now to our triangle, but our prototype still has red as the value. We can also do some other interesting stuff here. If instead of changing my triangle border, I changed my shape border to blue at this point, when we run the code, what we'll see is we get just blue, blue here. And that's because I changed a property of my object, and this triangle still points to that same object for its prototype. So it's getting the new updated value of it. It's not statically bound to whatever the value of that was at the time that it was set as the prototype. It's dynamically bound to whatever that value is at that point in time when that's called. And I could, for example, create another object. Let's say I create a square. And this is also an object. So I'm just going to go ahead or a shape of some kind. So I'm going to have it inherit from a shape. I'm going to make it a rectangle, so it at least has 2 properties. It'll still have a width and a height. And I'm going to copy these 3 lines down here and just change my triangle to a square. Oops, selected too many. Or rectangle, I mean. Change it to a rectangle. And let's see what happens when I print this out. What you'll see is the property for both the triangle and the rectangle for its border changed. And that's because they both have this prototype, this shape as their prototype. Now, if instead I did triangle border of blue, and we look at the code, we'll see that our triangle now has a border property that says blue. That's because we added it to the triangle object, not to the prototype object. So we get out blue when we're looking at the border, but its prototype still has red, and that didn't affect our square or our rectangle at all. And here we can change the rectangle border to be green, for example. And that'll operate that same way. We added something to our rectangle, but it didn't affect our triangle at all. So I hope those examples start to show what's going on working with the prototype, working with this inheritance tree. Now let's add something else that is a little more interesting than just setting a border. Let's add a function to this inherited object. Let's add a method of some kind. And what I want to add is compute area. So I want to be able to compute the area of my object. And here's what I'm going to do for that. I'm going to return. Now, there's some issues with this. You wouldn't do this exact way in real life. But what I'm going to do is just return this dot width times this dot height for my compute area. And now instead of focusing on my colors, let me print out let me inline some stuff here for this, some variables, so that this is sort of dynamic. Now I'm going to copy these, put them down here for my rectangle as well, and say the area of the rectangle. Oh, I need to change both these values to get this right. And then I need to call the rectangle compute area. All right, that was a lot of changes I made, so I'll probably have an error in my code somewhere. All right, it looks like I don't have a bug in my code, at least not obviously, but there is something wrong with it. Anybody want to tell me what's wrong with my code? And it doesn't have to do, obviously, with the code itself, but does anybody know what the formula for the area of a triangle is? I need to square. I need to, the formula for an area of a triangle is 1/2 width times height. So my problem here is I'm doing compute area, and width times height is the correct way to get the area of a rectangle, but it's the wrong way to get the area of a triangle. So we've got a problem with this logic. It's nice that we can reuse this compute area and we didn't have to define it in each one of our objects, but for my triangle, it's wrong. And this gets into this concept of creating a common interface or polymorphism. What I can do is I can change that behavior on my triangle, compute area, and I'm going to give it its own function. So now what I've done is I've added a method to my triangle, compute area. And when it goes to try to call this triangle.compute area, it's doing the same thing that it did before with the border property. It's first going to check the object for this method. And if that exists on the object that you're working with, then it's going to call that, as opposed to needing to fall back and check the prototype or the prototype or the prototype. Let's see if this worked. All right, I think it worked. So this is what's known as this concept of sort of polymorphism. What you can have is a similar interface, and as long as those objects implement the same interface, and in this case, the interface would be this compute area function. As long as they implement that interface, then you could put, if you had some bit of code somewhere, you could put the triangle in place of the rectangle or the rectangle in place of the triangle logically, and the code doesn't need to change. So I'll go ahead and give a more concrete example of what I'm saying there. Let's go back to what we were doing early on, where we sort of had this, the cart, and we were computing our total, right? Well, let's take these objects that we've got, and I'm going to add them to a shapes array. So after I've created each one of these, I'm going to push them into my shapes array, or I'll do it at the bottom so it's a little cleaner to see after all of these. Let me push this down. An extra couple lines. I'm going to do shapes.push my triangle, and shapes.push this rectangle. And now let me create another object, another one that has a width and a height as the two things that matter, which is, I don't know. I'm sure I spelled that wrong. Parallelogram. Let's just go with a square. Let's make it even simpler. And you'll begin to see some challenges here maybe, but here's one of the problems here. A square really only has one dimension. It has, since it's the same on each side, it's got a width of 5. It doesn't need a separate height defined because it's the same on each side. We want to change only one value. Or maybe that's length or something, I don't know. But that means that, again, our compute area function isn't going to work because it would fail. So if we tried to call that right now, like if we did a console.log square.compute area as our output from this, we're going to see not a number come back out. And that's because it tried to multiply 5 times undefined and gives us back not a number. That's not a valid operation. So for our rectangle, we also need to do something different, or a square, we need to do something different. We need to define our own method to compute the area. And this one is simpler. This one is return this dot width times this dot width. All right. Let's try that again real fast just to see if it's working. And we compute the area of our square. Let's see. Awesome. It looks like it's working. Question is here, is if I'm putting them into an array, couldn't I do an if statement in the original function that goes through and makes its calculations based on the elements in the array and just pass the array into the function? I'm not totally sure what's being said there, but I'm guessing you're doing some sort of logic to decide, is this a triangle or is this a square or is this something else? And if that's what's being asked, that is a possibility. You'll see that in code sometimes. But that makes your code pretty fragile because you're putting a whole bunch of logic in one place. You're putting a whole bunch of logic about different shapes all in one function, whereas instead you could put it with the thing that it belongs with, that computation can be with that object, and then we can write something that's much more generic and reusable, and that's what we're going to do just now. So now I'm going to go ahead and push this guy into my shapes. So I've got my square. Now what I'll have is an array of shapes, right? And let's go back to where we were before. Let's compute or print out the size of each one. I'm going to add one more property just to give us a little more context here. So each one of them is going to have a name. And that's just to give us a little bit more flexibility here. I know it seems a little redundant to be putting them like this after where we called it a rectangle, but we're going to lose that name or that variable context when we push them into our array. So I'm sort of adding it to them so that it's something that's useful to us in just a minute. Now let's say I want to print out the shape or the size of each one of these, the area. I can do that using our nice little, say, for each that we had before. So I'm going to write a function called print area of a shape. And we know that a shape is going to have a compute area method on it. So what I'm going to do is just go ahead and console.log the area of the, and then I want to get my name, shape.name is shape.compute area. So if I've got this function that can print the area of a shape, let me test it real fast. Let me get rid of these lines I had down here and instead just test it with print area for my triangle and see what happens. All right, the area of the triangle is 6. So I know that that's working. I'm going to leave that there for just a minute. But now I can go back to my for each, get all of my shapes, do my for each, and just call print area for each one. Oh, I don't need this last little print out. Get rid of that. And now we've got something that, look at how little code we have in this print area. This print area function knows nothing about whether it's a triangle, nothing about how to compute the area of our shape. And it doesn't know whether it's a triangle or a square or a rectangle. What it does know is that each shape has a name property and each shape has a compute area method, and that compute area method it trusts will give us back the correct area for that shape. And in this case, it uses the polymorphic nature, the ability to refer to the ability for each one of these objects to implement the same interface, to just call compute shape or compute area and get the right value because that object implements that interface. So that kept this function incredibly simple and incredibly reusable. We didn't have to write a complex if statement in here checking what type of shape do we have for each one of these. And instead, we kept that information on each one of our objects that we were creating. Any questions on that? All right. If not, I've got one more example we're going to work through a little bit. Let me look here. That was just another example of using the prototype chain. I don't think we necessarily need that. So let's go through the one other example I have. And this one I'm going to post just like I did with some of the stuff from the last class in the examples. And you're probably going to want to keep a reference to it because I do plan on writing one of your homeworks to leverage it or in some way to work with this. And that is we're going to create another character the same way that we have already been creating these characters. We're going to create a character. What am I going to call this? I'm going to call this farmer.js. All right, so we don't have much going on in here. We've got this character. He's got a greeting of some kind, and he's got some values. That's just going back to our object literal syntax that we had before. And we can always just test that this is working. So let me see. Oh, we get a nice little printout. You know, we could also do character.greetings. Test that maybe. Yeah, looks like it works. All right, I'm going to change this. I don't want to call him just a character. Let's call this a farmer to sort of represent this farmer. And let's say I've got another farmer that I want to create that's going to inherit the basic behavior of a farmer, but something about him is going to be different, right? I've got a nice object here to inherit from. What do I want to change about my other farmer? Well, I've got John Doe. Let's go with the famous farmer. Let's pick. How about Old MacDonald? Yep, I'm sorry, guys. A little bit of a kid song thing going on here. But we're going to create Old MacDonald. So based off what we did in the last exercise, we'll use this object.create, and we're going to have him set as his prototype the farmer object, the existing farmer object. And now let's check oldmac.greetings. Let's just see what happens when we print that out. Let me add something here. So I have some proper syntax, and we get, my name is John Doe. I am a happy farmer. We've got something wrong with this. His name isn't John Doe. So let's give him a correct name. Old MacDonald. because of that ability, that prototype chain, because we now set this on our old Mac object, it's going to go ahead and print out the right information for him. So he's going to have the correct information for what he is. Let me see here. It looks like I don't have the next step here. So the next thing that we're going to do here, let's build on this a little bit more, and then you guys should be able to use this as the base for solving one of the homework problems I'll be setting up. So what is Old MacDonald known for? Oh, now I got several people typing. Uh-oh. My computer went down. He had a farm? Anything specific about his farm? Yeah, he had some animals, right? So here's what I'm going to do. I'm going to create an animal object. Is his proto name still technically John Doe? Good question. Let's check that. And I really encourage you to play around with code like this too. If you're when you have that question, write a little bit of code to test it. Do like a console log old mac dot proto dot name. Let's see what we get here. Sure enough, his prototype name is still John Doe. And that's because this is still an object. I didn't change the value of this object at all. I only changed it on this new object. Going back to that picture that we have, I only changed it equivalent on this, but not on the object that it's inheriting from. But yeah, that's right. You guys got it. Old MacDonald had a farm with some animals, right? And one of the primary things the animal does is it speaks. So we're going to put a function on here of speak. And this is sort of trivial, at least at first, but let's just return. Let's assume that each animal is going to have some sort of saying. This, oh wait, I don't need to do this here. It's going to have a sound. I don't know what our base sound is going to be. Our base sound is nothing. They don't really say anything for the prototype of an animal. But they will, what this is going to do is this dot sound. So this speak is just going to return whatever their sound is. So now we've got an animal object, and we can start creating some animals off of that. Object.create. It uses the animal as its prototype. And there's a couple important things about an animal, which is, let's see, it has a name. This one is a pig, and it has a sound. Right? Now we can do console.log pig.speak. If we clean this up a little bit, what are we going to get? Oh, I want to get rid of this prototype bit here. And then we get our pig saying oink, right? And we can create some other animals using this exact same behavior and leveraging that same concept of maybe putting them in an array. And so what I'm going to have you guys build on top of this is basically you have an Old MacDonald object or a farmer of some kind. Going to create some animals. We'll do several more of the same way. And we'll add them all to an animals array. And then you guys will just need to write out a program that uses Old MacDonald and uses the animals to print out the song, Old MacDonald Had a Farm. So it'll just be a little bit of composition. And in fact, speaking of composition, part of what it'll be is I want there to be a farm object. The way we're going to do it is we're going to make a farm object. The farm object is going to have a couple things on it. It's going to have the farmer. In this case, that's Old MacDonald. And it's going to have the animals. And that's going to be this array of animals that will be created. In this case, we just have a pig. And in the portion that I'm not going to implement, but it's also going to have for the homework, will be the, what do I want it to be? It'll be the song. So that's where you'll need to implement this method. It will sing the Old MacDonald song based off of the properties on this object that we're going to put in there for the homework assignment. No, animals as not prototypes. So this is where you have to read very carefully. This is why the code is very subtle. So I may be misreading what you're seeing, but this is animals plural, and this is animals singular. And so we've got actually two different variable names here. So animal is a prototype for each one of these animals the same way. But animals is a property that I've added to this farm that's just a plural version. It's not the exact same thing. And they will have this prototype, which is why they'll be able to speak. So the way I want you to have them speak is to call the speak method of each animal in this loop or this song. And this is sort of a combination of several of the things that we've been putting together. So there's some prototype stuff, there's some composition, there's some inheritance, there's going to be some iteration. If you want to use that nice for each on an array, that might be a possibility for you. It depends on how you want to put this together. But it should make for a good assignment. And I'm going to post this up right after we finish this class, which will be a little early tonight, just a few minutes. But it's probably going to take me, honestly, it's going to be pretty hard to write the tests for this correctly. So I don't know if I'm going to have the tests done and have this up on REPL.it tonight. Might be tomorrow instead. So if it's not up there, I would still encourage you, the minute I get this posted up on the notes for the class, go ahead and take a look at it, take this code and start working on it, right? Maybe create some extra animals here. We can create another one. We've got a cow, our most classic version of an animal. And our cow has a name, which is a cow. And our cow has a sound, which is moo. We can put that in here too. So that's what you guys are going to be doing, sort of a combination of a number of these concepts. Nothing too fancy, nothing that's too complicated, but it should definitely challenge you to put pieces together that you guys are having to learn. Any questions about that? All right. Feel free to hit me up if you have any questions tonight on anything. Let me know if you've got anything else that you want to go over. Again, I do still plan on creating some shorter videos on some of this stuff. I've got software on my other computer to do that, and I was struggling trying to figure out how to get it all working correctly and produce the way I want. I want those shorter videos to have a little bit higher production value than what I'm doing for these classes. So hopefully I can get that figured out sometime soon. Otherwise, I'll see you guys on Thursday. And again, if you're having any problems with the homework as well, let me know about that. All right, talk to you later.